Now let's continue talking about firms' demand for factors. In the previous videos, we already discussed firms' demand for labor. But we said that, in at least in the neoclassical model introduced and discussed in this chapter, we will have capital and labor, okay, the two factors, and sometimes we would even talk about technology. Okay, so here, let's briefly discuss the firm's demand for capital. Okay, you would find that this discussion is very similar to what we already did in the previous videos. So if you already had a solid understanding of the firm's demand for labor, here its demand for capital should be relatively straightforward. Okay, and so let's start with the definition of the marginal product of capital, MPK. Again, here K stands for capital. Okay, MPK is defined as the extra amount of output the firm gets from one extra unit of capital, holding the amount of labor fixed. Okay, again, remember when we discussed the MPL, that's a marginal product of labor. We held the we held the capital constant and let the firm adjust its use of labor. And here we do the opposite. We hold the labor fixed and let the firm adjust its use of capital. In other words, the machinery, equipments, and tools. Okay, and see how it would be able to maximize its profit. Okay. Now, before we talk about the profit maximization with the adjustment of capital, we would briefly talk about this very important thing. Okay, it's a LDR. The marginal product of capital decreases as the amount of capital increases, holding the amount of labor fixed. It is also called the LDR, law of diminishing returns, or diminishing returns to capital. Okay, again, you find we already discussed LDR in the previous video, but that's LDR to labor. Here it's to capital. Okay, now what's the economic intuition behind this law? Okay? You could imagine that in front of you there's let's say a lot of math problems you need to solve. Okay, probably the assignment you got from your math professor. Okay? But you don't have any other tools. Okay? You don't have the computers or calculators. The only things you have is pencil and paper. Okay? So you have to use the traditional way to solve these problems one by one. And suppose that spending 1 hour you would be able to solve, let's say, 100 problems, math problems. Okay? And now, if we give you, let's say, like a plain calculator, okay, and you still spend 1 hour, you would be able to solve probably 200 problems. Okay, so number of problems solved doubles with a plain calculator. Okay. Now we keep giving you more equipment or tools like a computer, so you could use Excel, okay, helping you, or other math software helping you solve the problem more efficiently. Okay, now you can solve, let's say, 250 problems within an hour. Okay, and so again you become more and more productive, right? But if we follow this direction of thinking and keep adding more and more capital to this case, in other words, we give you the second computer, the third computer, the fifth or the 10th computer, you would find that the productivity of the computer, not the worker, okay, the productivity of the computer gets lower and lower. Okay, because again here we hold the labor constant, so you are the only problem solver here. Okay, the only human. In this case, you only have a pair of hands and one brain. You just cannot, with 1 or 2 computers, you can probably still handle it, okay, and make the the problem-solving process very efficient. But when you receive the 10th computers, you probably have nothing you can do with that, right? So that's why we believe there's going to be a diminishing returns to the machinery, equipment, or tools if the labor in production is held constant. Okay. All right. So once you understand that, then there's a IFAD review example. Okay. Once again, IFAD is instructional technology I used during the face-to-face instruction. Okay, it's a pretty simple bubble sheet to help you get instant feedback. All right. But here you can try your best to solve these, okay, the multiple choice. The problem itself is about the difference between returns to scale and returns to input. Okay, if you remember in the previous section 3.1, we talked about returns to scale, and we said there are 3 types of returns to scale. They are constant returns to scale, CRS, increasing returns to scale, IRS, and decreasing returns to scale, DRS. Okay, so here this multiple choice says, could a CRS firm have diminishing returns to its labor? Okay, then we give you 5 different choices. Okay, in other words, we're trying to figure out if there's any connections, okay, between the returns to scale and returns to input. All right. Again, try your best to find the answer to this one. Okay, and later during our virtual meeting, we will be able to discuss these more in depth. Okay. All right. So here we already wrap up our discussion about firms' demand for labor and capital. All right. And then in the next video, we will start talking about the market equilibrium, okay, for these factors of production. All right, and we're going to use primarily the graphical way to drive the equilibrium condition. Okay, and then on the top of that, we would be able to talk about the distribution of income between the workers and capital owners.